Hi, so in this we will discuss LeetCode problem 1894. Find the student that will replace the chalk. Okay, so there are n students in a class numbered from 0 to n minus 1. The teacher will give each student a problem starting with the student number 0, then the student number 1, and so on until the teacher reaches the last student n minus 1 student, right? After that, the teacher will restart the process, starting with the student number 0 again. Like it means it's circular, right? Like from 0 to n minus 1, then again from 0 to n minus 1 in this way, right? So you are given a 0 index integer array chalk and a integer k. There are initially k pieces of chalk. Okay. When the student number I is given a problem to solve, you will use chalk I pieces of chalk to solve that problem. However, if the current number of chalk pieces is strictly less than chalk I, then the student number I will ask for replace for the chalk. So we have to find out the index of the student that will ask for the actual replace of the chalk. Okay. So for this example, let's go to the example 1. Okay, so chalk are actually 5 on 5. And initially how many actual chalk I have? 22. Okay. So question solve will start from student number 0. So first 0 student will solve. Okay, so student number 0 and chalk number of chalk present actually 22. So how many actually chalk needed to student 0? 5, which is actually less than actually available chalk. So this student will not ask for a replace of chalk, right? So I will solve this, and after this number of chalk available will be 17. So now I will go to the student number 1, right? Next student number 1, how many actually chalk needed for this student? 1, but I have actually 17. So this is actually enough, so I do not need to ask for the replace. So number of student after solving this problem, number of chalks will be available is 16. Now I'll go to the student number 2, right? So how many chalk needed for the student number 2? 5, and I have actually 16. So this is enough, so I will not ask for a replace. So how many chalk will be available after solving the problem for student number 2? 16 minus 5, 11. Now I'll go to the student number 0. This is a round. I have completed one round. So now I'll go to the student number 0. So how many chalk are available? 11. How many actual chalk I need? 5. So this is enough, so I will not ask for a replace. So this will actually 6. Number of chalk will be available after solving this will be 6. And now we'll go to the next student 1. So how many chalk I need? 1. And how many chalk are available? 6. So I do not need to call the replace, so I will solve this. So now go to the next student 2, and how many chalk will be available? 5. 6 minus 1, right? Now student number 2, how many chalk I need? 5. I have also less available chalk is 5, so I don't need to call. When we call a replace, when our available chalks are less than needed number of chalks. Got it? So that's why I will not call. This is equal to. So now go to the student number 0, and number of chalk available is 0. That time I will check how many actually chalk I needed. 5. Student number 0 need 5, but how many actually available chalk are there? 6, which is actually greater than 0 available note chalks is less than the number of chalk needed, so I need to call. So what is the index of this? 0. That's why answer is 0 for this example 1. Index number 0. Student 0 will ask for the replace. Got it? So now go to the example 2. Example 2 is 3, 4, 1, 2. 3, 4, 1, 2. And number of chalk initially available is 25. So first I will solve for the student number 0. How many chalk are available? 25. Okay. So how many chalk are needed to solve? 3. Right. So how many chalk will be available after solving this? 25 minus 3. This will be actually 22. Right. Now go to the next student number 1. How many chalk are needed? 4, which is actually greater than less than 22. So I don't need to call. So available chalk will be 18. Now go to the next student 2 is 2. Student number 2. How many chalk are needed? 1. So this will be, I don't need to call because 18 are available. So this is enough. So number of chalk will be available after solving 17. Now go to the next student 3. How many chalk are needed? 2. So this is enough. So k is equal to 15. Number of chalk will be available will be 15. Now go to the again next student will be 0. After 3 it will be again, this is actually circular, right? So student number 0, how many chalk needed? 3. So this is enough. So number of chalk will be available at 12. So now go to the next student 1, how many chalk are needed? 4. So how many actually chalk will be available after that? 8. Now go to the next student 2, how many chalk are needed? 1. So how many chalk will be available after this? 7. So now go to the next student 3, how many chalk are needed? 2. So this will be minus 2. So how many chalk will after that? 5. Now go to the again student number 0, right? How many chalk are needed for student number 0? 3. So this is actually enough. So after that number chalk will be 2. Now go to the next student 1, how many chalk are needed? 4, which is actually less. I need actually 4. That time what happened? This is actually minus, negative. That time I have to call. So which student will ask for replace? Student number 1. That's why you can actually check answer is 0, 1. Student number 1. Got it? Understood the logic, right? So what is actually simple approach to do? Here's what is happening simply. So what do we do? How many actually total chalk we need? Okay. This is suppose our sum. Okay. And we know that what is the initial number of chalk are available. Okay. So here actually, what is actually sum is actually 5 plus 1 plus 5. This is actually 11. And initially I have actually 22 number of chalks available initially. So how many round are possible? 2 round are possible, because I can actually divide this 22 by 11. This will 2. This, that's why you can actually check, like again 0 1 2 0 1 2, then again 0 1 2, then I am coming to this third time. That time it's getting replace, calling the replace function, right? Replace the chalk. So that's why you can check how many actually complete round is possible. How many complete round are possible? Okay. So this is suppose I know that okay, x number of complete round are possible. Okay, then I will check how many actually chalk are remaining after that. Like if I do that, like 22 modulo of 11, 0 number of chalk will remain after 2 round of question solving. So what will happen? Whenever again going to solve this the third time, that will check okay, number of available chalk is 0. And and then I will actually traverse this array only once. That time actually available to solve this. How? Like suppose the next example 2, sum is 3 plus 4 plus 1 plus 2. So this is actually 10, right? And initially available chalks is 25. So how many actually complete round are possible? That will be possible 25 by 10. 2 round are possible. So in 2 round we don't need to do anything. We don't need to worry about the check about that we need a new call the replace chalk or not. Okay. So after 2 round, how many extra chalk will remain? 25 modulo of 10. This will actually 5. Then I will start iterating the array. This array. Okay. So this will what will happen? 3, 4, 1, 2. This is our array. Okay. So I'll check for the student number 0, how many chalk are needed? 3. So this is actually enough to actually do this to solve the problem. Yes, actually this is enough, because I have actually 5 chalk still there and I need actually 3. So how many actually chalk will remain after that? 2. Then I go to the next student. Okay. So how many actually chalk I needed? 4. But how many actually available? 2. So that time I will say okay, I don't have the that minimum number of chalk, so I need to call. And what is the index? 1. So that time I will return the index of this. Got it? So so what we're doing, we just call the prefix sum. So then first of all, this actually store the 0 to 0 sum of 0 to 0 student, then 0 to 1 student, 0 to 2 student, 0 to 3 student, right? So in this end index, I know that how many actually round are possible. This is actually total sum 0 to 3, right? This will be stored in the last index. So I will just do k by this prefix sum of n minus 1. These actually give the total sum and how many actually initially chalk are available. Okay, now how many chalk will remain after that? K modulo of prefix sum of n minus 1. This chalk will remain after that. I will just then iterating that, okay, this 0 0 sum, suppose x, y, z. Okay, then I'll check what is the remaining chalk are available, that I actually can solve the problem or not. So I know this x is, if x is less than the remaining, then I can solve 0 to 0 student. Then I go to the y. This is 0 to 1. So I'll check y is less than remaining number of chalks. If it is the less than, then I can actually solve this 0 to 1 student, right? If it is, suppose y is less, y is greater than, suppose y is greater than the remaining number of chalks, that time I have to call this, and for which position I will call this one index, because I know this is the sum total number of chalks I needed, and what is the remaining number of chalks that is actually less, that time I have to call. But in this actually I can actually call this. So what is actually solving this? Just go to the code. Initially this actually our id is equal to -1. Okay, and I will find out that how many actually chalks are there, means students are there. Okay, they have mentioned that chalk size will be the number of students. Now I am calling this prefix array that actually store the sum of 0 to I, and size will be n. So initially prefix of 0 index will be sum will be chalk 0, because this is the first student number 0, and for I is equal to 1 to I less than n, I plus plus, I am storing this. What is the previous sum? This is actually previous sum, and what is the current chalk? Got it? We are storing this into the current prefix sum I index. That actually we already know this. This actually the prefix sum of I minus 1. And if we add this x, then I can actually say that this actually a sum of prefix of I. Prefix of I will be what? Prefix sum of I minus 1 plus x. That's a prefix sum of I minus 1 plus the current number of chalks required for the current student. Okay, this actually we will assign to the prefix of I. Got it? Now what is going to happen? Now I will check how many actually round are possible, because this will actually otherwise actually like time complexity will be more, because we are how many complete round are possible. That time actually still we are going to round and check that this actually still actually our chalk is less than or not. Got it? That's why I'm checking how many actually complete round are possible. That how we actually get number of initial chalk are available and total number of chalk required to complete one round. That will be stored in the prefix sum of n minus 1. Got it? Now what I will do? I will do that. What is the remaining number of chalk cards available? So you can also do that k minus k remainder of sum. This is also possible, and here actually I have done this by in this way, like k will be k minus like number of complete round is d and the sum. This is also same, both are same, right? Okay, so in this actually I have actually done this. Now I am calling the iterating the prefix sum function. So first 0 index I am starting from I 0. Then I'll check what is the number of chalk required for 0 to 0. If our current remaining k is number of remaining chalks is greater than the current needed chalks. If it is greater than, then we don't need to call the replace function. Then I will go to the next prefix index, next prefix sum array index. So that will be what is 0 to 1. Then we'll check, okay, what is the sum of 0 to 1 index, 0 to 1 student. Then we'll check what is the sum. So suppose sum 1. If it is the number of chalks needed is less than the remaining available chalks, that will be actually we don't need to call. Again, go to the next 0 to 2. In this actually check on whichever index I will actually find out which number of available chalks is less than required number of chalks. That time I actually break, this while loop will be break, and I'll return that I index. Got it? In this actually, what a time velocity is big of n, because here actually you can check that we are iterating that chalk array only once, and here also we are traversing that prefix sum array, right? And what is the space complexity? Like we're taking a new vector of size n, so that's why the space complexity big of n. So can actually optimize this? Yes. How? Like big of n, we can actually time velocity will be not actually optimized, but we can actually optimize the space. How? Like here actually you can actually, one thing actually you can observe, like we're actually creating a new vector, right? But you can actually don't need to use that. Why? Because if we take only one variable, suppose sum, they're actually storing the total number of chalks required for the array, student array. Okay, that allows to only store sum plus chalks I. Okay, now you already know that this will be actually work like k by sum it will be work, and k modulo of sum it will give the remaining number of chalks. Now whatever you're doing in this while loop prefix, using this prefix sum, you need to check one thing, like if we subtract sum minus chalks of I, this also give us the remaining number of chalks are available after processing the student number 0 problem, right? Then again go to the next, while sum greater than equals to chalks I, that will actually work. How? I will just subtract the number of chalks required for this student chalk I, then I plus plus. Got it? And whenever the remaining number of chalks is less than the chalk required for the student number I, that time it will break if it is less than, and return I. In this actually we are not using that prefix sum array, so that time actually our space complexity will be here big of 1, because we are only using a variable sum. In this actually we are using this, right? What is the logic, right? Understood the problem and the code also, right? Thank you, and please subscribe the channel. Okay, and if you have any feedback you can actually comment on the comment box. Okay, thank you.